Most people struggle with designing furniture, especially when it comes to laying out angles and curves, not to mention proportions, dividing sections, and the order of events in building a furniture piece. I want to show you some clever ways to help make designing furniture easier as well as fun. Have you ever wanted to visualize three-dimensionally what you envision in your mind's eye just before you start the project? Well, I encourage you to make scale models or mock-ups out of either cardboard or foam board like this. This foam board is available at craft stores such as Michael's or Hobby Lobby. You'll also need some masking tape, you'll need a straight edge, you'll need an X-Acto knife, and a hot melt glue gun. And I'll work right from my sketches to build the project. It'll take about 15 or 20 minutes to make a quick, three-dimensional model of my project. I can then make any necessary changes to the form, proportion, or the appearance, or even the function of the piece. This makes for a quick way to see your project first before you even cut a board. You can also do the same thing on a larger scale by making full-scale mock-ups out of cardboard like these. Simply cut the cardboard out, take duct tape, tape it all together, and use a magic marker to draw in all the details. Now I can look back and examine the form full scale. One easy way to make a small wooden mock-up can best be described by making a small hallway table. Start by developing the shape of the top of that table, and I'll do that by drawing at least 10 different shapes that tabletop could have. I'll then choose the one that I like the best. I'll then take a scrap piece of wood that's been milled to approximately 1/8 the scale of what that table is going to be, and then I'll go to the router table and I'll cut the shapes that I wanted that tabletop to have. After I've got my profile cut, I'll go to the front view of what this table might look like and proportionately draw it out as well, then draw shapes for what the front of each one of those tables might look like. I'll then go to the bandsaw and cut them out so that I have a whole bunch of these little tables that look like this. I could then evaluate the form and choose which one I like the best and then build that table. If mock-ups aren't your thing, then I recommend that you do a full-scale drawing such as this chair. I can get the three-dimensional feel by walking around the project from a distance. I'll face it from the front, then from the side, and then from the back. This will give me a fairly accurate idea of what this piece will look like in each of these perspective angles. I do this walk around on all of my full-scale drawings. In my furniture making video, I discuss my simple rule of square first, do your joinery work, then cut to size or shape last. Once you understand this rule, the entire order of woodworking becomes a logical order of events. It's a simple rule, but if you understand and follow it, the process of furniture making will always be easier. Let's break that rule into its three parts to better understand what they mean. Design everything square first. Accurate woodworking involves total control while you're machining each part. Each machine in the shop has some type of control. All shop equipment is designed to cut wood at either 90 degrees or 180-degree angle. The point is this: when you design furniture, make sure you plan on all wood meeting at 90 degrees even if it has radical curves or bends. Do your joinery work while all of your pieces are nice and square. Look at the side view of this chair. You see all these curved flowing lines in here. But when you look closer, you can see that each piece of wood meets another piece at 90 degrees. Here's a better example of how this works. Look at each one of these chunks of wood. Nice big rectangular but square all the way around. This piece could go here. This piece could go back here. This piece would go here. And this piece would go here. Now what you see is a big chair. Every piece meets another piece at 90 degrees. But once I take my patterns and put on each one of these, I'm going to move this because that's the seat. This is the front leg. This would be my back leg. This would be my seat. The arm. Look at how each one of those pieces can be cut out of those big chunks Every piece meets another piece at 90 degrees. So right now, while I've got a big square piece of wood, I can go through and do all of my joinery work, then come back and cut everything to shape last. This is how this rule works. Square first, do your joinery work, then cut to size or shape last. Probably the best known and most widely used proportioning system is the golden section, which seems to satisfy our sense of harmony and proportion better than any other. The golden section is a line segment divided into a larger and smaller section so that the ratio of the short section to the long section is the same as the long section to the whole, which is about 5 to 8 mathematically, or 1 to 1.618. The golden section can be applied to furniture to help develop the form as well as specific details in the piece. Here's how it can be used. On a 36-inch tall table with a 3-inch thick top, using the golden section to divide the legs into sections, it would give me an overall leg length of 33 inches. If you divide 33 by 1.618, it'd give you a bottom part of the leg that's about 20 inches in length and leave a remainder of about 13 inches for the top section of the leg. The proportion between the two sections on the leg will be eye-pleasing. The golden rectangle comes from the golden section. We know that the golden section divides a line segment into 5/8 and 3/5 section lengths. The golden rectangle adds the 5/8 section to its length as height to create a square, as this graphic illustrates. Let's say that we wanted to make a chest of drawers, and we wanted to know what the correct proportion should be for the drawer height. Well, you can use the golden rectangle to divide it out like this. Draw a square, which is to the width that you want your cabinets to be, and extend the sides up the square. Draw a diagonal AB. Open up a compass to the length of the diagonal of AB, and draw an arc connecting B to the vertical line drawn at point A. This will intersect the vertical line A at a new point C. From point C, draw a perpendicular line to the vertical line from point B to form point D. Draw diagonal AD. Open the compass to the length of the diagonal AD and draw an arc from D to the vertical line at point A. This will intersect the vertical line A at a new point E. From point E, draw another perpendicular line to the vertical line from point B to form point F. Continue this until you have the number of drawers that you want on this chest. You've made a chest with a perfect geometric progression. I always make patterns for my originals by using tracing paper. I put the tracing paper on top of the pattern that I want to duplicate, and then I trace it. I then transfer that drawing to a piece of 1/4 inch thick plywood. I transfer it by using carbon paper. After it's transferred, it'll leave me with all the right markings. I'll then go to the bandsaw and I'll cut this shape out so that I end up with a permanent and very accurate template. The best way to make patterns that repeat their shape from one side to the other is by using tracing paper. Let's say that we're making a decorative valance to tie two cabinets together. I'd start by drawing the outside dimensions of the valance on my tracing paper. Then fold it in half so that the pencil marks realign themselves just like this. This crease will show me where the center point is. Now design a curve shape on 1/2 of your tracing paper. When you're happy with the design, refold the tracing paper and realign your pencil marks and trace the curve on the folded side. See, it's a perfect symmetrical match. I can tell what a curved line or details will look like before they're completely drawn out by using a mirror. Let's say that we wanted to make a stringer for a table that had a series of cutouts in it. By drawing half the stringer with the cutouts darkened in and placing a mirror at the halfway line, it will reflect the entire image. It's now easy to see what it's going to look like and make any adjustments. you can do the same thing with wood and veneer to determine how it would look if it's to be book matched like this. Here are a few good ways to lay out curves and curved lines. The most obvious way to lay out a curved line from point A to B is to use a metal straight edge. Take the straight edge and bend it between the two desired points, then have someone take a pencil and mark the line. We'll use a black marker to help you see it better. There it is. A bowstring will give you a great degree of repeatability and can be easily used by just one person. It's nothing more than a thin stick of wood, approximately 1/8 of an inch thick by 3/4 of an inch wide, by whatever length you need. Drill a small hole 1/4 of an inch in from each edge. You also need a small stopper piece of wood about 1/4 of an inch thick by 3/8 of an inch wide by about an inch long. This small stopper piece will get 2 holes drilled in about 1/4 of an inch from each edge. The string gets knotted at one end of the stick ran through one of the holes on the stopper, and then into the other hole on the other end of the stick, and back to the stopper where it'll be knotted. You now have a bow stick that can be used to lay out curves to any radius. If you use a tapered piece of wood in your bow stick instead of a straight piece of wood, you can create asymmetrical curved lines with total repeatability. My stick starts out at about 1/4 of an inch thick here, and it goes down to about 1/8 of an inch in its thickness down here. And then when I set the curve, you can see how it's asymmetrical in the way it runs through. I sometimes find that the best way to lay out a quick curve is to use my elbow as a pivot point, just like the pin on a compass. With a pencil in my hand, I'll create a pretty accurate curved line just like this. I could do the same thing on a much smaller radius by using my wrist as the pivot point like this. And the most common way to lay out a curve is to take a straight piece of wood, like this, drill a hole in one end and hammer a nail in to act as the pivot point. Then I've drilled a hole down on this end that I could stick my pencil into. So now I could come back, hammer in my nail, and I've got a perfect device to draw out arcs. Whenever you're evaluating the fluidity of a line, such as the curves on this leg of this chair, don't look at it from a distance. The focal point of your eyes can't absorb the entire curve vertically. Instead, look at it horizontally. By looking at it horizontally, I could see every one of these little curves and bumps and divots along the road here. But when you look at it from this view, it looks straight. Dividing out sections can be done in a lot of different ways. The most common way is to use dividing calipers like these. They work on both straight and curved lines. A perfect example of how they work would be to locate the spindle placement on a chair. If I wanted 7 equally spaced marks along a curved line, I'd start here and work my way down 1, 2, 3, 4, and so on until I got all the way down to the other end. The idea is when I get to that last position that this last tip should come exactly on that pencil mark, leaving 7 equally spaced holes or lines between those 2 tips. You can also divide any shape into equal sections by using a tape measure or a yardstick like this one. Let's say that we wanted to divide this piece of plywood into 5 sections for drawers. By laying the yardstick diagonal from one side to the other and using any multiple of 5, since there are to be 5 openings, align the yardstick to the multiple of 5 that's larger than the opening width of what our drawer will be. For this size, I can use either 20 inches or 25. Let's go ahead and use 25 though. So with the edge of my yardstick on one side of the plywood and the 25-inch mark on the other side of the plywood, I can now go through at each 5-inch mark and put spots here, 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 here. Or if I'd used 20 inches, I would have gone every 4 inches. I can now take a framing square and line up with my points. And right there I have 1, 2, 3, 4, 5 perfectly equal sections. You can also divide out lines by using a metal tape measure. By taking the overall number you want to divide and then bending your metal tape around so that the end touches the exact number to be divided, just like this. For example, if I wanted to figure out what, we'll take an easy number, let's just say it's 36. What is half of 36? If I touch my end of my tape on the number 36 and then come back and look, I see that 18 is exactly the halfway point between those two. I can add and subtract numbers easily with my tape measure as well. For example, if I wanted to add 7 3/16 to 26 5/16, all I have to do is bend my tape around so that those two numbers line up like this. So I've already marked on my tape 7 3/16, and I've marked on my tape 26 5/16. When those two numbers line up, the end of my tape shows me perfectly 33 1/2, which is exactly what that length is added to it. I can subtract in exactly the same way, only this time I would need to deduct the smaller number instead of adding it. Making angle cabinets can be very difficult, especially when it comes to making them fit tight against an angled wall like these do. I've found the best way to make these cabinets fit perfectly against the wall so that the outside angles of the cabinets fit flawlessly was not to measure the angle of the wall with a protractor, but to take off the angle with a template. This graphic illustrates an angled wall. In order to make an accurate template of this angled wall, I would start by cutting 2 strips of 1/4-inch plywood, 24 inches wide, since that's how wide the cabinets were, by a full 8 foot in length. Start by placing the first piece up against the wall and tighten to the corner. Place the second piece on the other wall so that it overlaps on top of the other piece. Right here and here are where the angles will intersect at the distance equal to the width of the soon-to-be-made cabinets. By marking these 2 points on the top piece of plywood, then taking a straight edge and drawing a line connecting the dots, I can then cut right on the line with a jigsaw. I can now set this piece right on top of the other piece and transfer the angle mark to the piece underneath. This bottom piece can also be cut with a jigsaw right on the scribe mark. These 2 pieces should be a perfect replica of the angle of the wall. I can now duct tape the 2 pieces together in my shop and build the cabinets right on top of this Luan pattern, making cabinets that fit the angle of the wall perfectly. You can make your marking gauge mark on curved surfaces by carpet taping on 2 dowel rods just like this. And now I can take a curved surface and that'll follow perfectly around the outside edge. People often ask me how I lay out my dovetails so perfectly without measuring. Well, here's my secret. I use my sliding T-bevel as its own measuring device. You see on this T-bevel, this distance, and this distance are all the same. So when I put my bevel at the angle, and I come and put it on my piece of wood to start marking it out, if I line up this outside edge, then I could mark off of either here, here, or here. Let's just say right here. When I flip this around the other way, and I line up the same reference point with the outside corner, when I come back and mark again in the same place, those are exactly the same distance in on both sides, and even though I didn't measure them, they're right on the money. I could then come back and I could line up either here, here, or here, anywhere I want. We'll line up the outside right there. And once again, I could mark here, here, or here. This time let's use the outside. When I come back over here, I'll do the same thing again. And mark back this way. That X is exactly in the center of that piece of wood. This is a converging chart. It's a simple layout tool that can be used to help divide out dovetails. I make my chart by cutting a piece of plywood 12 inches wide by 18 inches long, then dividing the width into 1 inch long sections, and then the length into 1 inch sections. I then measured in 1 inch from one side in exactly the center point, which is right here. I then drew radiating lines from that point to each one of these 1 inch mark sections down here. I then took a framing square and I drew my perpendicular lines again at every 1 inch mark. By drawing this chart out this way, I can divide this piece of wood in however many equal sections I want. And if I start here, I can have this many sections drawn in that. Or if I move it down to here, I can have 6 exactly spaced sections in that piece. If I move it down to here, I end up with 3 lines or 4 sections in that piece. The most common way to lay out angles for dovetails is by using a ratio. The most common ratios for either hardwood or softwood are between 1/6 to 1/8. This chart helps to explain where those ratios come from. Start by drawing a line 10 inches long, perpendicular to the bottom edge of a square piece of plywood. And then measure over 1 inch to the right and 1 inch to the left. Next, make marks on the perpendicular line that are 1 inch apart. With the straight edge, connect the 1 inch mark on the right to the 6 inch mark on the perpendicular line, and then from the 1 inch mark on the left to the 8 inch mark on the perpendicular line. These two lines will give you angles that are just right for laying out dovetails. However, I find it's a hassle to constantly set my sliding T-bevel to these angles, so instead I've made wooden blocks that can be used over and over again with total accuracy. These first blocks are nothing more than wedges with either the 1/6 or the 1/8 ratio on them. See how they work? I could just set it right on top, and I could mark off my pins and my tails with these little wedges. These, on the other hand, are a little bit different blocks. These are for laying out both the pins and the tails from both the top side and the side. Let's just take this one, it's 1/6. When I put it in place, I can draw out my angle, but because this has a straight side down here, I can come back and draw this face and this face, where the other wedges don't allow me to do both the front and top at the same time. Very, very creative little marking devices. The figure of the grain on doors should always have the cathedrals running up instead of down. This will give the door a presence of stability and strength. If you want to make a box that has a continuous grain all the way around, the trick is not to cut a piece of wood in order from here to here, because 3 of the sides would match, but the 4th corner wouldn't line up at all. So the best way to do it is to resaw the board and then divide it like this. Here's a great way to accentuate a curved line by choosing wood that has a diagonal end grain and orienting it so that the growth rings slope up from the front to the back. The grain will give the curve a magnified curved effect. If you make a table that has curved legs, you can use the grain to help accent the curve just like the curved line before. By running the grain outward from the center of the furniture piece, like this, the grain will follow the curve of the leg. If you run the grain in the opposite direction, it'll fight the natural curve of the leg